In our last video, we started looking at some ways to simplify expressions with rational exponents that are fractions, as long as our base was the same. In this video, we're going to look at what to do if our bases are not the same. It turns out that there are some things that we can do as long as we're working with the same root or the same exponent. If that's the case, there is something we can do. So our first example has the cube root of 12 times the cube root of 18. Well, because both of those are inside the same radical, they're both inside of a cube root, I'm allowed to go ahead and multiply those two numbers inside together. Multiplying 12 by 18 gets me 216. Notice that my root didn't change, it stayed the cube root. What I said in the last video, my rule of thumb is whatever starts out the same stays the same. So the cube root was what matched up in the original problem, so that stays as a cube root. Now always try to simplify further, so what I would do is on my calculator, if I wasn't sure, I would try to do the cube root of 216. If it comes up as an integer, which it does in this case, the cube root of 216 is just 6, then that's all I need to do, I'm done. If I were to get a decimal, an irrational number, I'm not allowed to get decimals when I simplify. Simplify never means get decimals. So I would need to do something else, which we'll take a look at in the next video. My next example. Notice this time my bases are different, so I'm not going to use the rule we talked about previously of adding exponents. That only works when your base is the same. But notice my exponent is the same. Both of them are raised to the 1/2 power. So as long as something's the same, there's something you should be able to do. In this case, I'm allowed to multiply those two bases together and get 16, but then that's still raised to the 1/2 power. Your exponent won't change. Whatever starts out the same stays the same. Keep in mind, as we've talked about previously, exponents can be the same as roots. So in this case, I could rewrite this problem as the square root of 16. If you can simplify, make sure you do. The square root of 16 is just 4. So I can simplify this to just a 4. Continuing along the bottom, notice I've got the 4th root of 80 divided by the 4th root of 50. Because they're both inside the same roots, I can go ahead and divide those numbers like I would normally divide numbers. So 80 divided by 5 gets me 16, and then once again I want to try to do the 4th root of 16. I would probably reach for a calculator first if I didn't know what the 4th root of 16 is, and I would see that the answer is 2. It is rational, it's an integer, so that's fine. If it wasn't, once again I don't want any decimals, so in the next video we'll take a look at what to do if that does come up as an irrational answer. And then one more example to do when our bases are different. There's a couple ways you could approach this problem, but what I would do is probably start out with what's inside the parentheses. Both of them are raised to the same exponent, 1/3. Remember, if you wanted to, you could rewrite that problem as the cube root of 42. All the problems on this page are pretty much the same thing because I could replace the exponent with a root or vice versa, and I can change the format if that made the problem easier for me to do. In this case, I'll just leave it as is. I'm going to divide those bases because the exponents do match up. 42 divided by 6 gets me 7, and then the exponent of 1/3 will stay the same since it started out the same. I now have 7 to the 1/3 squared, and my rule for raising a power to a power is to multiply, like we talked about in the last video. So to finish this out, I'm going to have 7 raised to the 2/3, which is irrational, so I'll leave it alone and say that that's my simplified answer.